Hi, I'm Daniel Mandler, a professor of chemistry at the Hebrew University of Jerusalem. The story I'm going to tell you might eventually have a huge impact on the emission of greenhouse gases, and particularly carbon dioxide. And the story started in the Dead Sea. The north part of the Dead Sea, its level of the water goes down by approximately 1 meter per year. The reason for that is that on one hand, less water goes into the Dead Sea from the Jordan River as well as from other sources, and at the same time, water is taken from the north part of the Dead Sea and is brought to the south part of the Dead Sea by both potash companies, the Israeli and the Jordanian. On the south part, the level of the sea goes up by approximately 20 centimeters per year. And this happens because in the process of taking out the potash, water is evaporated and first sodium chloride precipitates. The government of Israel, together with ICL, decided to take the sodium chloride which precipitates there and somehow to travel it back to the north part of the Dead Sea. This is going to cost to the Israel society a tremendous amount of money. At that time, I started thinking, what can we do with such a huge amount, particularly 20 million tons of sodium chloride annually? Can we do something else with it? It's a byproduct that nowadays is useless. And actually it causes tremendous problems, environmental problems. I asked myself, where can we use such large quantities of sodium chloride? And the answer was, or at least I thought the answer was, in construction. In dry places like in the Salar in Bolivia or the Sahara in Egypt, people used to build their houses made of salt. Every few years when it rained, they had to rebuild their houses. On the other hand, there is another material, cement. The production of cement, which adds to 4.2 billion tons annually, is directly responsible for between 8 to 9% of the total emission of carbon dioxide to the atmosphere. These are such large numbers that we cannot even imagine them. And it must be replaced. We cannot go on and continue using cement. Can salt be a good substitute for cement? We started working with it. It was so crazy that initially we did not even ask for funding. After 2 years of working, we had so many results that I applied for some grant, obtained it. We developed a very simple and a green process which takes place at room temperature as compared to cement, which is produced at 1500 degrees. We take the sodium chloride, which precipitates in the Dead Sea, we grind it, we add about 5% of very cheap materials, then we compress it under relatively large pressure of 2 tons per square centimeter. We get a brick which does not need really any glue inside. The bricks that are formed are even much stronger, by 5 to 10 times stronger than bricks made of cement. Initially, we thought that we'll have to coat these bricks by something which is impermeable to water. But we very quickly found out that when we compress the sodium chloride and we add some specific materials that make it very hydrophobic, this coating is not really needed. These bricks are much more stable in water than regular salt. They can be glued, they can be drilled. It's a material which has not been used so far for construction. It has huge advantages. Besides being green, it's not toxic. It can be recycled. Salt is also antibacterial. Salt is actually very healthy. As you might know, people pay a lot of money to stay in salt rooms. Is salt going to replace cement? The world is standing on a brink of destruction. We are suggesting salt bricks for construction.